We're in our TCP/IP Basics course, and in this video we're going to talk about private versus public IP addresses. So what's the problem? Why do we need public and private IP addresses, and what do they mean? Well, when we invented the IPv4 version 4 IP addressing scheme back in the 50s and 60s, they came up with a scheme that was 2 to the 32nd power, which is only 4 billion IP addresses, and we far surpassed that a long time ago. But IP version 6, which we're now adopting, wasn't quite ready yet. So it wasn't happening quickly enough. Sort of like the metric system. It's out there, but we never really quite adopted it quickly enough to be useful. However, now that is absolutely changing since we've handed out all the public IPv4 addresses. But we would have handed them out a whole lot sooner had it not been for this solution that scientists came up with. So the solution was to choose a reserved block of IP addresses for internal use only. And by doing that, it allowed a lot of businesses and homes to use IP addresses over and over. You could use the same ones. Now, originally, when the Internet IP addressing scheme came out, there was no way to do that. You could only use one IP address once. You couldn't use it in multiple different times. But with this new reserved block of IP addresses, we have IP addresses that cannot be routed. So they're only used for internal use. So I can use the same, say, 192.168 address that in my house or my business that you can use in your house or business. So we get to reuse the IP addresses. Well, how do we do that? We do that using what's called network address translation. And what it does is it hides our internal IP addresses. And it allows us to use the same IPs over and over. So how does this work? When we use an IP address such as 192.168.1.1 and we go out to the Internet, we don't broadcast our internal IP address. We broadcast the public IP address that's on the outside of the firewall. And it uses something called HideNAT. HideNAT basically hides all of our internal IP addresses through one public IP address. It's a one-to-many relationship. And the firewalls actually were not invented when the Internet was first invented itself. So they didn't even think about firewalling. They didn't think about security. They didn't think about ways to extend our IPv4 IP addressing scheme. And when we realized we needed all these things, we needed to protect our networks, we needed to preserve our IP addresses, that's when all these kinds of things came about. So firewall natting, network address translation, basically hides our internal actual IP address from the outside world. So that way we can use the same IP addresses in many businesses and homes at the same time. So which addresses can we use for this new internal routing type of scheme? Well, it's not new anymore, but it was new back in the early 90s. Well, we've got the block that we see here, 10.0.0, which we used to refer to as a Class A block, but now we're using a lot of what's called classless IP addresses, which we talked about in a previous video. So that gives us 16 million hosts. That means we can plug in up to 16 million computers and phones and tablets. Not many offices are going to really need that many. But if an address starts with 10, you know right off the bat that is an internal address. So you can go ahead and use that at your home or business. Another block is the 172.16. Now, unfortunately, they made this super confusing. So 172.16, so 0 through 31. That means starting at 172.16.32, then you now have a public IP address. But if the third octet that you see there starts with 0 through 31, that means it's an internal address. So by default, it's a /16 address, which again, we used to call it Class B. And so that allows us to have 1 million plus hosts. Then there's the more common one that people use, 192.168. So if you see an IP address that starts with 192.168, once again, that is an internal IP addressing scheme, and you can use up to 65,000 hosts. Now, through subnetting, which we've covered a little bit in previous videos and we'll cover in upcoming videos, through subnetting, we can change this to be a /17/18, but typically the most popular one is a /24, which gives you 254 hosts. So internal use only. They are never used externally. That allows us to reuse these IP addresses since they're not out on the public domain. Cannot be routed outside your local area network. And they can be used by everyone. So when your internet provider sends you a router, a lot of times they have one of these three internal IP address schemes built in. For instance, Comcast typically uses the 10 network address scheme, whereas most others use the 192.168 addressing scheme for internal IP addresses. So many times in homes anyway, people don't even have to be IP literate. They'll just plug in and automatically get these internal IP addresses. But you're going to be IT administrators, and so you need to understand why you use these internal subnets and which internal subnets are out there for your use. By using non-routable internal addresses, we have temporarily solved the lack of IPv4 host problem. At some point, just about every device that can be plugged into a wall will have an IP address. And this is going to cause us to eventually move over to IPv6, which has trillions of IP addresses available per person.